Hey everyone, I am SATTWIK. Wishing you all a very happy new year. Hope you are doing well. Today, we are going to solve the recent CodeChef contest, that is Starters 219. The first question is cake baking. Okay, the question says chef knows n customers will come to his bakery today, and so he has baked m cakes where it is given that m is always greater than equals to n. Now every customer needs at least one cake, otherwise they will for sure be unhappy. Further, if a customer is able to buy two or more cakes, then they will be happy. Now chef wants to maximize the number of happy customers while not having any unhappy customers. What is the maximum possible happy customers? Okay, so essentially we are given two variables, that is m and n, where n represent the number of customers and m represent the number of cakes. Okay, so we have given two things. First of all, if a customer receives no cake, that is zero cake, then he is unhappy. And if received greater than equals to 2 cake, then he is happy. Okay, now we have been told that we need to uh, complete two objectives. The objectives are, first of all, ensure that no one is unhappy, and maximize the number of happy. Now let's first solve the first issue. Okay, so to ensure that no one is unhappy, we at least need to give them one cake. Zero cakes mean unhappy, so if I give at least one cake to all the customers, then they are not unhappy. Okay, so there are m cakes and n customers where m is always greater than equals to 1. So in order to give one cake to each customer, I will take n cakes from m, that is m minus n cakes are remaining, and I will distribute those n cakes among the customers. So for example, if there are 5 cakes and 3 customers, customer 1, customer 2, customer 3, I will take 3 from 5, 2 cakes are remaining, and I will distribute the 3 cakes among 3 customers. That ensures that none of the customers are unhappy. Okay, now coming to the second objective, that is maximize happy. That means I need to maximize the number of happy customers. That means I need to maximize the customers having greater than equals to 2 cakes. Now coming to this example only, 2 cakes are remaining. Everyone has received one cake, so I just distribute the rest of the 2 cakes to 2 customers. I mean, there is no other choice. I will give 2 cakes to 2 customers. If I give 2 cakes, both the cake to C1, then only one customer is happy because one has 3, another have 2, one each. Now, but if I give one cake to C1 and one cake to C2, that means C1 and C2 both have 2 cakes and C3 have 1. That means C1 C2 both are happy. So always after performing the first objective, that means subtracting n from m, the answer will be m minus n. That means only m minus n customers can be happy. Okay, so there is an edge case, that is always is m minus n always the answer? In cases where m is very large than n, for example, if the number of cake is 8 and the number of customer is 2, first what I do, I will take two cakes from m and distribute it between the 2 customers. That means only 6 cakes are remaining. Now what will be my answer? My answer can't be 6 for sure, because the number of customers is 2. How can 6 customers be happy? So my answer will be minimum of m minus n and n, because the upper bound of my answer is always the number of customers. Okay, now let's code this up. We have been given two variables, that is m and n. We take, now my answer always will be, now let's assume we have performed the first step, that is take n from m. Okay, so after that my answer will always be minimum of m minus n comma n. Okay, so I'm okay. Sorry, I think the input format is first n then m. Sorry, n then m. Yeah. Okay. So moving forward to the next question. The next question, the name is pizza comparison. Okay. Chef makes two types of pizzas. A small pizza with length 10 inches costing A rupees. A large pizza with length 15 inches costing B rupees. His customers are wondering which pizza is more optimal to buy if they want to maximize the amount of pizza received per rupees spent. Okay. For comparing, we will be assume the amount of pizza to be its area. Okay. Output small if the small pizza has more amount of rupees spent. Large if the large pizza have more amount of rupees spent, and equal otherwise. Okay. So essentially in the second question, we have been told there are two types of pizzas. First one is small pizza. Okay, so first of all the pizzas are square. The small pizza have side 10 inches and the large pizza have side of 15 inch. And we have given two variables a and b. A is the cost of the small pizza and b is the cost of the large pizza. Now the code wants us to give which is more profitable or which provide a better size to price ratio. Okay, and for comparison, from comparison of the size, it's been said that we use the area of the pizza. Okay, so the area of the small pizza will be 100 because the side is 10 inches, and the area of the large pizza will be 225. Now what I just need to do is that calculate the cost per area. Okay, so cost per square inch of A. Cost of A will always be the area of the small pizza divided by the cost per square inch, and similarly the cost of the large pizza will be 225 by b. Now I compare them and provide the result. Now one thing I need to make sure that the cost A and cost B should always be in double, because there can be decimal point values. If it's integer, then we are going to lose some decimals and the comparison can be tempered. Okay, let's code this thing up again. We are given two variables a and b, the cost of small pizza and large pizza. Now calculate their cost per square inch, sorry, cost of A. Okay, so first of all it will be double, 100 divided by B. Cost A and cost will now represent the cost per square inch of pizza A and pizza B. Now I just need to compare them. If cost A double equals to cost B, then just write equal. If cost A greater than cost B, that means मतलब छोटा वाला ज़्यादा सही है. That means small, else the large one is most profitable. ठीक है. Okay, let's okay, so small large equal large small large equal small large equal large small. Okay, so yeah, now moving to the third question. It's new operation. Okay, Now coming to the third question, that is new operation. You are given an array of n integers. You perform the following operation n minus 1 times. Choose an index I such that I is greater than equals to 1 and less than the size of the array, and let x equals to a of I plus 2 into a of I plus 1. Delete a of I and a of I plus 1 from the array and insert x back into the array. At the end of n minus 1 operations, only one element will remain. What is the maximum and minimum possible value of the last element? Okay. So in the third question, we have given an integer array of length n. Okay, now we need to perform an operation n minus 1 times. The operation says that first I will select an index I. Okay, so I am reordering the index from 1 base indexing to 0 base indexing, so don't get confused. So in each operation I will select an I such that I should be greater than equals to 0 and less than n minus 2, less than equals to n minus 2 or less than n minus 1. Now greater than equals to 0 and less than equals to n minus 2, I need to select an index. Then I perform this operation, compute x. X should be array of I plus 2 into array of I plus 1. Okay, now I remove both a of array ith and I plus 1 index from the array and insert x back. That means for an array, let it be I and I plus 1 index and the rest of the array. I need to select I, then compute x based on I and I plus 1, then remove I and I plus 1 and insert x in its place. So for an example, 1 1 1, no sorry, let it be 1 2 3 4. Okay, so first I can select any index from between these three. Let me select the third one, that is I equals to 2. I will select I equals to 2, then I compute x, that should be a of 2 plus 2 into a of 3. That means it is 3 plus 2 into 4, that means 3 plus 8, it's equals to 11. Now I remove both I equals to 1 and I equals to 2, that means this 2 will be removed and in its place 11 will be inserted. That means my new array will be 1 to 11. Now I perform these operations n minus 1 times. That means for this the size of n is 4, so I will perform it 3 times. After performing 3 times, only one integer will remain. I need to provide the maximum and minimum value of the integer. Okay, now focusing on the main operation, that is x equals to a of I plus 2 into a of I plus 1. Now the main factor that actually affecting the size of x or the value of x is 2 into I plus 1. It will contribute more to the size of the x, so I need to maximize this value every time. Now as x is always greater than a of I and a of I plus 1, that means after computing x, I always try to put x here. I always try to put x in 2 times value, because if I only add x, then it won't contribute much to the size. So what for the larger case, what I will do is that for any array containing 0 1, any array containing this number of element n minus 1, n minus 1, I will always start my operation doing from here, that is n minus 2. I will compute n minus 2, n minus 1, store the result in n minus 2 and then move left. That means every time I am computing x, and then in the next iteration I am using this x value here in multiplied by position. For example, let me have the same array 1 2 3 4. In the first operation I will start from n minus 2. So what I will do is that I will compute x. X should be a of n minus 2 plus 2 times a of n minus 1. That means it will be 3 plus 4 into 2, it is 11. Now I remove both this and this and insert 11 in place of a of I. That means my new array will become 1 2 11. Now again I start here, that means n minus 2, then perform x equals to 2 plus 2 into 11. That means this time it will be 24. My new array becomes 1 comma 24. and for the last time I perform, it will be 1 plus 2 into 24, that means it will be 49. Okay, so the largest value or the maximum value is 49. Now first let's code for the maximum value, then I will move to the minimum one. I have given okay, the input format gives me t. I have already handled the number of test cases. Okay, so after that I have given the size of the array and the integers. Okay, so in n, c in n, I declare the array. Now let's take the input. Okay, now let's make another copy of this array. Okay, so it will be required. I can also do it with variable, but it's just more intuitive. Let's make another copy of nums. Okay, now let's move ahead and compute the maximum value of the after performing all the operations. Maxima. Okay, so what I just told, I will start from n minus 2 and compute it, and every time try to put my first computation in the 2 multiplied by this position, because it will have the largest impact. Okay, so I will move from n minus 2 towards left. I should be 0. Okay, what I'm doing is that first nums of I will always be plus equals to 2 into, okay, just let me write it clearly. X equals to nums of I plus 2 into nums of I plus 1. Now let's store. I'm removing nums of I and nums of I plus 1 and storing x in place of nums of I. So nums of I will be x, and I just move towards the left. Okay, so as I'm moving towards the left, it will be I minus minus. Now let me just check. My last answer will be stored in the 0th index, so nums of 0. Check for my custom input. So 1 2 3 4. Let me just check it. Okay, so there are some errors. Okay, so I need to declare it. For okay, yeah, so it's coming all right. Now moving to the minimum value of the last after performing all the operation, the minimum value I can achieve. Now it's almost similar to the maximum approach, as it's guaranteed that x is always greater than a of I and a of I plus 1, and x equals to a of I comma plus 2 into a of I plus 1, as these have the maximum weightage to the value of x. So I always try to, after computing x, I always try to keep the larger value here and the smaller value here, because if I keep the larger value in this position, in 2 multiplied by position, then it will always increase the value of x. So I will always try to compute x and put it here and compute the next element in position of 2 into a of I plus 1. that will ensure that I will always receive the minimum value. So the approach is all, in the previous approach I move from left to right. In this approach I will move from right to left. Sorry. In the previous approach I move from right to left. So in this approach I will move from left to right. So that means every time I will always start from 0th index, and every time I compute a of, okay, I will compute a of I. A of I plus 1 should be a of I plus 2 into a of I plus 1. That means, for example, 1 2 3 4, I will start from 0th index. I will compute the value of x. It will be I plus 2 into 2. That means it will be 5. Now I remove 1 and store 5 here. Now in the next index, see that as 5 is greater than 1 and 2, I will not put 5 in 2 into a of I plus 1 on a position, because it have the majority impact on the size of the last value. So 5 will be placed left. That means in the next operation it will be x equals to 5 plus 3 into 2. That means it is 5 plus 6, that is 11. In the last operation, okay, now my array becomes 5 will be removed and my array will become 11 comma 4. In the last operation it will be 11 plus 8, that is 19. That is the minimum value. Okay, so let's code this up. Now come calculating the minima. For this I will be using the another array, because first one is distorted due to finding maxima. This time I will start from 0 and it will go till n minus 1 plus plus as I move from left to right. So it will be I plus plus, and now I calculate x. It should be, sorry, nums of I plus 2 into nums of I plus 1. Sorry, here I am using nums 1. I plus 1. Now I am storing it in I plus 1 as I am moving from left to right. It will be x. So yeah, and my final answer should be in nums of last n minus 1. Okay, so let's just remove it and print the minima and maxima. Scout. Okay, here it will also be nums 1. So the minima is stored in the last index and the maxima is stored in the first index. Okay, so it will, yeah, let's just check. Yeah, let's check on the given inputs. Okay, it's working. So essentially what I am doing is that for maxima, to achieve the maxima, I am performing all the n minus 1 operation from left to right, starting from n minus 2, and to find the minima I am performing the n minus 1 operation from, sorry, in case of maxima I am performing from right to left from n minus 2, and in case of minima I am performing from left to right from 0, starting from 0. And now coming to the fourth question, ones and zeros. Okay, ones and zeros of 1. Given a binary string, f of s is defined as follows. A prefix s of 1 comma I is called good if it's contain at least as many ones as zeros. F of s is number of good prefix of the string s. Okay, you are giving a binary string s of length n, find f of s. Okay, so in the fourth question I have given a string s, a binary string s containing 0 and 1. Now it have defined a function f, and f of s is the number of prefix, the f of s is the number of good prefix. It is the number of good prefix, and a prefix is called good. First of all, a prefix is a subarray or a substring starting from 1 to any point I. Okay, so if a prefix is called a prefix is called good if the number of 1 in that subarray or a substring is greater than the number of 0, greater than equals to. For example, uh, let's take an example, 0 1 1 1 0. Okay, 0 1 1 1 0. So first, counting all the prefixes, first it's 0, first prefix is 0, the number of 0 is 1 and the number of 1 is 0. So okay, let me number of 0, number of 1. Okay, in the first prefix number of 0 is 1 and number of 1 is 0, as number of 0 is greater, so it's not a good prefix. Coming to the second prefix, that is 0 1, the number of 0 is 1, number of 1 is also 1, as both of them are equal, that means it is a good prefix, so my count will be 1. Now coming to the third prefix, 0 1 1, the number of 0 is 1 and the number of 1 is 2, as number of 1 is greater than equals to 1, so that means it is also a good prefix, so my count will increase by 1. And coming to the fourth prefix, it will be number of count of 0 is 1 and the count of 1 is 3, so another good prefix is there. And the last prefix is 0 1 1 1 0, the count of 0 is 2 and the count of 1 is 3, number of 1 is actually greater than number of 0, so it is also a good prefix, so my answer will be 4. Now let's check. Yeah, the answer is 4. Now a naive way will be computing all the prefix and calculating the value of 0 and 1. I think it will take around no, actually even if I perform naively, that means if I start from left to towards right calculating the number of 0 and 1, it can be done. So basically the approach will be track the number of 0 and number of 1. Number of 0 and number of 1, you should track that and move from left to right. As it is prefix, that means it will always start from 1. So move from left towards right and always after increasing number of 0 and number of 1, always calculate it if the number of 0 is less than number of 1. If it does, then just increase your count by 1. That means okay. Okay, in this question I have given n. This is the size of the string and the string itself. Now I initialize two variables, the count of 0 and count of 1. Now let's I will traverse the array from left towards right, or the string, sorry, for if it is 0, then count 0 will increase, else count 1 will increase. If count 1 is greater than equals to count 0, let my answer also be 0, and initialize the value of count 0 and count 1. Okay, so if count 1 is greater than equals to count 0, then my answer will increase. Okay, let's just check. Yeah, so it's a pretty simple question. Yeah, now coming to 3 parts, the last question, 3 parts. Okay, so in this question, for a given binary grid A of size n cross n, we define function f of a as the number of distinct write down paths that can be taken from 1 1 to n n, such that all the cells I, j you have visited have a of I, j is equals to 1. So we are only moving through the cells which have value 1. and f of n is defined as the number of distinct paths we can move from top left to bottom right. Okay, a write down path means that the cell x comma y you can only go either to x plus 1 comma y or x comma y plus 1. That means I will either from any cell I will either move from towards right or towards down. Okay, construct a grid A with exactly 3 paths or claim there does not exist any. If multiple answers are possible, all will be accepted. Okay, so essentially I will be given an integer n. Okay, first of all, the okay, it is the fifth question. We are given an integer n. Now for a grid n cross n grid, let n be 4. Yeah, a function f of, I think, yeah, a. Okay, the binary grid A. Binary grid means that the value inside of the cell will either be 0 or 1. A function f of a is defined as the number of routes by which I can travel from top left, that is 1 comma 1 to n comma n. Now it is also given that okay, so it is a number of count. Now it is also given that we can only travel through the cell that have value 1. For example, now okay, let me draw it clearly. And let me do it for 3 comma 3. For a binary grid, the number of way I can reach from top left to bottom right is that, first of all, on also it is mentioned that I can only use write down movement, right? Yeah, write down movement. That means I can only go towards right and towards down. Okay, so for for this example array, the number of ways I can move from 1 comma 1 to n comma n is that first path will be this, another path can also be via this. Yeah, that's all. So there are only 2 paths by which I can move from top left to bottom right. That means f of a for this grid will be 2. Now the question tell us to, for a given n, the question told us to create a binary matrix such that f of a is always 3 and exactly equals to 3. Okay, so for we are told to provide a binary matrix such that f of a is equals to 3 for any given n, and if it's not possible then just write -1. Okay, so first of all, for any matrix, the it's a purely visualization problem. For any matrix, if I just need to ensure that only 3 paths are available from top left to bottom right, one of the solution on the pretty naive solution can be just create a path like this and just add 2 here. This will ensure that there is at most there is exactly equals to 3 paths. The first path will be always the entire line, and the next path I can diverge from here and come down, and the third path can be I can diverge from here and again come down. This ensures that there are exactly 3 paths for any size array. For example, if I even take a 5 cross 5 matrix, if I take a 5 cross 5 matrix, okay, sorry, if I the same pattern, if I follow the same pattern, that means this and the rest are 0, this always guarantees that there are exactly 3 paths. I am calculate a single path, the first single path through here, sorry, calculate a first single path through here and just add one in here and here. This ensure that there are exactly 3 paths. I can diverge This is the complete path, and now from this point I can diverge and come down. This is the second path, and now from this point I can again diverge and come down. This is the third path. This ensures that there are always three paths. Now coming to the case where it is not possible, for the situation where n is less than equals to 3, sorry, n is less than 3, that means we cannot create a path with exactly we cannot create a grid with exactly 3 paths from top left to bottom right. If n is less than equals to 2, that means the answer should be -1. Okay, now let's code this. So only one input is given, that is n. Okay, now let's just create a grid, empty grid. Okay, first thing first, just if n is less than 3, just it is not possible, so just write -1 and end. In the else part, I initialize a grid. Yeah, okay, so first thing I need to do is that first I cover from 0 to n-1 up using for the first row or the 0th row. For the 0th row I will cover the entire column with 1 except the last column. That means for first 0th row, for int I equals to for this, I am doing this for the 0th row, that means of I will be 1 except the last column. That is that for that reason I have rather than n I have used n-1. The first part is done. Now coming to this line, that means I am now covering the n-1 column for all the rows. So for sorry, not n-1 n-first column, it is n-second column. So for sorry, I'm covering the n-1 first column for all, sorry, n-first column for all the rows. Okay, so that means up till this line, and this line is done. Now what I need to do is that just make these 3 cells 1. That means starting from the last for the last column, starting from the last row till n-3. Yeah, starting from last row, that is n-1 till n-3, for the last column I am going to make all of them 1. That means for starting from the last row going to n-3, and also it's for the last column, so that means n-1 will be 1. Yeah, so let's just print the grid. Yeah, let's just run it. Okay, so so there is a spelling mistake. So yeah, I think it's working. Let me check for 5, for large number like 5 or 6. Yeah, you can see there is a path. From here I will go down, and there are two additional cell with one, so I can divert from here and here. So it will ensure that there are on exactly 3 paths. Start for from top left to bottom right. So I think this will work. Yeah, so it's working. So that's the end of today's video. Again, wishing you all a very happy new year. Keep enjoying and coding. See you soon in the next video. Thank you.